there's a way to go from grams of something. I'm just going to call it X, whatever it is. So chemical, something, element. I can go from, let me make a longer arrow there. I can go from grams of something to moles of something. And then I can go from moles of something to molecules or atoms of, well, you keep the X. So in the atoms is if it's basically an element and a monoatomic element, right? Like zinc or aluminum, right? Molecules like water or some diatomic molecules. Some elements are actually diatomic, like hydrogen. We talked about that briefly when we did naming. Okay, and so I can go from grams to moles. I can also go from moles to grams. The arrows go both ways. To go between, oh, it looks like, really? Okay, so let me just say the meeting's going to end in 10 minutes and basically we'll just start over. So don't leave. Okay, is everyone clear on that? I hope everyone's clear on that. Yes? Okay, no one's saying anything. So I'm assuming you'll log back in 10 minutes and we can look at this. So anyways, you can go
Your
from grams to
autofocus is
moles.
being really chunky.
You guys, sorry?
Your autofocus, it keeps like zooming in and then zooming out.
Yeah, and I don't know what to say. It looks like the camera automatically finds the background. And so if I'm not moving, then I think it stops. But when my hand's in here while I'm writing, see that? So it's like, oh, your hand, now there's a new layer. Which layer do we want to focus to? So if you guys want, I could pause it so that the image will stabilize. You can just say that. Is that cool? Or is
Yeah,
this, would you rather, I could type in the whiteboard if you don't like the document camera. I can also do that. Would you like that?
this is fine.
Okay. All right. So I'm just trying this and we'll see how it goes. So anyway, so we can go from grams to moles. So sorry, it's going to do that. To do that, does anybody know what's the conversion to go between grams and moles or moles to grams? What do we need? Okay, say it just a little bit louder. Someone said it.
We have to divide for molar mass.
Yes, so I think I heard molar mass. Oopsie. And how do we find molar mass? That's from the periodic table. Okay. And then we can also go from moles of something to its formula. So basically, whether it's molecules or atoms, I guess it's always the formula, right? And we can also go from number of molecules or atoms to moles. What's the conversion for that one? Does anybody know? So that is Avogadro's number. 1 mole of anything, 1 mole of anything is 6.022 times 10 to the 23. I'm just going to put things. It's really context dependent. And it's a bulk number. It's just like a mole is like a dozen, right? Okay. So if we do that, we could find out how many moles of carbon in 35.8 grams. So I mean, I could go back. I'm sure she's talked about this. We could go back and define this more literally, but I'm just going to show the setup, and I hope that's okay. So this lecture is kind of a shortcut to a full lecture period lecture. But so how would we go? How many moles in how many moles of carbon are in 35.8 grams of carbon? Question mark. And so basically I look up at this thing and I think of this as the mole subway. And each place is a stop. Right? So I have to know basically which station I get on. There's the gram station, the mole station, or the molecule atom station. And then based on what station I'm at, I know which train I'm going to need. So if I'm at the molecule station, I want to go to the mole station, I'll need to use this train, which is, this is a conversion, right? Moles to things. If I'm at the mole station, I want to go to the gram station, or vice versa, then I'll use the molar mass, and that's calculated from the periodic table. So let's look at this question here. Which station am I at?
Be the moles, right?
I'm sorry?
Would it be the mole station or?
Well, actually, I would look at what they actually give me information about. They gave me information about grams. I would say I'm at the gram station. Yeah?
Mm-hmm.
So I'm starting over here and I want to go to there. Yeah? So let's start. So I have, well, let's actually, I need to find my conversion. I need to find the molar mass of carbon. And if I look at the periodic table, I don't know, when we have these lectures, by the way, it would probably be handy for you guys to have a periodic table in front of you. But if you look at the periodic table, you see some numbers. You see that and that. What's my useful number here when I look at the periodic table? What do I want?
12, right?
I'm sorry?
The 12?
Yeah, the 12.01. So that is the mass of one carbon atom in the units of atomic mass units, or it's the mass of 1 mole of carbon in the units of grams, right? So that's my conversion factor. So from the periodic table, I get 1 mole of carbon is equal to 12.01 grams, okay? And so then I'm going to plug that in. I have 35.8 grams of carbon. And so I want to set this conversion factor up as a fraction, right? Times something over something. What's got to go on the top?
Moles?
Yep. 1 mole of carbon on the top. And then I want, on the bottom, I want grams of carbon to cancel, right?
Yeah.
And so grams of carbon cancel. Let's get some other pens out here. I think this is working out all right. This is my blackboard. Okay, we can also count significant figures. How many sig figs is this?
3.
Good, 3 sig figs. What about this one here?
4. No.
I'm sorry, I heard 1 and 0. I would actually call this 4 sig figs.
4. Yeah.
So the 1 comes about by per mole or by division. If I were to flip this over, this number here carries the measurement. So someone had to measure that mass, whether it's in atomic mass units or grams. So that's the periodic table, even though it's from the periodic table, it's a measurement. Okay. So how many sig figs should my answer then have?
3.
3.
Yeah, exactly. 3 sig figs. That's what I heard.
At least.
Okay, so then it's just a simple calculation. I get on my calculator. Should I show my calculator? All right, so what was it? Oh, 35.8 divided by 12.01. And so I get 298. Oh, I got lucky. I ended on a 0. All right, but anyways, my answer would then be, I'd round it to 3 sig figs, 2.98 moles of carbon. Yeah?